Welcome to an example where we've got a function. This is going to be, I think, a pretty challenging one. I'm going to color code it. So we have first off this first function, minus 5x squared minus 7 to the third. And then we have a second function, 2x squared minus 3 to the 14th. Okay. And they want us to take the derivative, f prime of x. Okay, how do we do it? Well, the big picture, the outer thing is this product rule, right? It's product rule. It's two functions multiplied. So the product rule says if you have, f times g, you want to take the derivative. Um, you do the first one, keep the second one unchanged, leave the first one unchanged, do the second one. They take turns. So this guy first. Let's do his derivative. Now, how do you do his derivative? Well, the trick is, and the reason I'm saying this is product rule, because these are two functions times, right? There's no symbol in the middle, but we understand those parentheses mean multiplied. So it's two functions of x multiplied. That's the big picture. Now, within that, this first function has a function inside of a function, doesn't it? Chain rule inside of product rule. Two chain rules inside of an overall product rule. That's what we have going on here. That's why this one's so tough. Because now this right here is the inside function. And this right here is the outside, right? And so how do we do that? That 3 comes down. Keep the inside unchanged at first. Then lower the power by 1, 2, right? Times the derivative of the inside. Inside function derivative, that's going to be minus 10x. Did you track with that? I'm far from done, but I want to make sure you understood what just happened. I just did the quotient rule. Maybe good if I wrote, I'm sorry, the chain rule. I wrote the chain rule up here as well. The chain rule says that when you have um, an outer function and an inner function, the derivative is the outer function's derivative, keep the inner function the same, times the inner function's derivative. That's what I just did here. I had to take the derivative of this function, which is a function inside of a function. So how do you do it? Do the outer. I brought this 3 down, lowered it to 2. Keep the inside the same at first, inside the same, times the derivative of the inside. See right here, this is the derivative of the inside right there. Derivative of this. It's minus 10x because that 2 comes down, subtract 1 from it, it's just x to the first. And the derivative of the minus 7 is just 0 because any number alone without an x, derivative of 0. Okay, that's all just the derivative of the first function. In this structure, that is all f prime right there times the second function, no change. So 2x squared minus 3 to the 14th plus, right, that's G. I'm doing the f prime G plus, now f, plain f, no derivative. That's the first function, oops, which is minus, well, here, let me keep it below, minus 5x squared minus 7 to the third with its power with everything. That's the whole first function, right? That's the first of the two functions. That's f right there. Times, and now, got some room over there, I need to do g prime, right? G prime is the last thing. That means the derivative of this guy, the second guy. Well, how do you do his derivative? Same thing. The outer's got to come down. 14. Keep the inside the same at first. Lower the power. And 3. Lower the power by 1. 13, subtract 1 from the power. Times the derivative of the inside function, which is 4x. Right? Derivative of that inside, 2 comes down, 4x, lower the power by 1. The 3 minus 3 goes away. Whew. That's there's F, there's G prime. That is ugly. Now we have to do a little bit of cleanup, unfortunately. There's a big plus sign in there. Okay. What are we going to do? Well, here's what we're going to do. This is going to be the mess continues. So what we need to do is we need to factor out some common stuff. See how this has a 3 in the front there and a minus 10x? I'm going to put those guys together to be minus 30x. Let me scoot over just a little bit. Minus 30x, right? 3 times minus 10. And then we have the minus 5x squared minus 7 squared, and the 2x squared minus 3 to the 14th plus. What about these guys? What do they have in the front? They have a 14 and a 4x. 4 times 14 is that 56? X. And then they have the minus 5x squared minus 7 to the third, and the 2x squared minus 3 to the 13th. This making sense so far? I just combined the numbers and letters in the front and the numbers and letters in the front. Okay, now with these two, these two, here's how you want to look at this is one term and this is another. Here's the big separator. Pluses and minuses outside of parentheses are the big separators. There's two terms. That's how you should look at that. And what do they share? What do they share in common? Like, what do they both have in common? Well, I don't know. I think minus 30x and 56x both have in common 2x. 2 goes into both of them. Well, forget that. Never mind, never mind, never mind. Just kidding. Let's forget about that. Let's just forget about that. And instead, let's just go for let's just go for what they have in common with the big terms, like this guy and this guy. This guy has got a second power, and this guy's got a third power. So you take the lower powers. Let me write that. Take out as a common factor the lower power of each term. So I'm gonna go, okay, minus 5x squared minus 7 to the second, because 2 is lower than 3. And then with the other term, the 2x squared minus 3. This is a 14th power, and this is a 13th. I'm going to take the lower one, 13. Then I'm going to put a big old bracket. You don't have to do a bracket. Parentheses is fine, but I just want to be super clear. A bracket is not any different than a parenthesis. It just helps me to see it better. You can do a parenthesis if you want. Okay. What's going to be left inside? Well, what's left inside, it'll be minus 30x, and it's going to be 2x squared minus 3 to the first power plus, I might be losing you right now. Let me see. See, if I took all of this and multiplied to all of that, do you see I would go right back to that? Do you see that's true? Do you see that? Because I've got the blue term to the second power, and that's right there. I got the green term to the 13th, and then one more is 14. And I get the minus 30x right there. You see? And now I'm going to come to the next one, and I'm going to go, okay, 56x right there. And I'm going to put the blue term. which is minus 5x squared minus 7 to the first. Let me close this off with again, brackets are the same principle, just easier to see. You see that if I took all of this, multiplied there, it go back to this, and multiplied there, it would go back to this. Do you see that's right? Because I've got the blue term to the second times the first, that add up to the third. And I get the green term to the 13th. That's what you get right there, 13th. And you get the 56x in the front. That was tricky, right? I took out as a comment, I took out the lower power on the blue, 2, and the lower power on the green, 13, and that left a little green and a little blue. Okay. So now, I know that's a tricky step. We do that sometimes in calculus. This is a C of algebra. I know it's not easy. You didn't think calculus was going to be easy, did you? All right. I'll quit saying silly things and let's keep going. So now I can clean up the inside a little bit. First power so I'm going to just distribute, whoops, through there, boom and a boom. And what am I going to get? I'm going to get minus 30x times 2x squared is minus 60x to the third, because it's x to the 1, plus negative 30 times negative 3, 90x. Okay, plus, and now this 56x is going to go boom, boom. Oops, I missed that second one a little bit. Boom. So what is 5 times 2? That's 250 and 30. So 280x cubed, because x to the 1 and x to the 2, minus 7 times 56. It's getting a little big for me doing it in my head here. 7 times 56 is my calculator. 392. So 392x. Okay, to see what I did there? I just took 56 times minus 5 and got that. Oh, wait, it should have been minus, shouldn't it? They should both have been minus. What am I doing? I'm messing up. This is tedious stuff. Should have been minus. Let's try that again. Minus, right? So plus 56 times minus 5 minus 280 x cubed, and then positive times negative is negative 392 through 350, and we're to 392 x, right? All right, we're almost there. Bring this down. Minus 5x squared minus 7 squared, 2x squared minus 3 to the 13th. And what's left in this bracket? Well, let's combine some like terms here. Minus 60x cubed minus 280x cubed. That's minus, what's that? 340x cubed. Just like terms, right? And then how about these guys? Plus 90 minus 392. Isn't that minus 302x to the first power? Like that? Man, I think that's basically it. Let's go check. Do we get minus 340x cubed minus 3? I'm looking right here at the answer. Minus 302x and 13 and 2 power. Yeah, I think we nailed that thing. That was pretty horrible, wasn't it? So there we go. There is the drill. So look back over that. That was a long one. And there we go.